Welcome to the third section of our course. It's about the computer network protocols and the meaning of the word protocol in the world of computer networks. What is a protocol in the world of computer networks? It's a set of rules and agreements that governs the communication process, the process of sending and receiving. It includes these rules and agreements, the addressing, the routing, the session management, and the error recovery processes if needed. How to address the machines, how to route messages between the machines, how to start and stop any session between any two machines, how to recover the loss or the duplication of any data between two machines. The mail network, the post network, the courier network, the traditional mail network is an example of a network with a protocol. Imagine that you need to send a mail, a certain mail that is written on a paper and included inside an envelope. You should write on the face of the envelope the address of the man you are going to send the mail to. And you will also have to write on the back of the envelope the address of yourself. This is a protocol that dictates on you some rules and agreements on how to write the address, where to write the address, and on which piece would you write the address, which is the envelope here. The envelope here includes the headers of the data, and the message itself written in a paper inside the envelope is the data itself that needs to be sent between the sender and the receiver. The PSTN, the public switched telephone network, is another network that is running through a protocol. Every telephone has a unique number that is worldwide, not repeated, and that is worldwide connected to the geographical location of this telephone. The mobile phone network is a network that has also a protocol. Each mobile phone number is unique. Each mobile phone number has a route to another mobile phone number in the world. Each mobile phone number can start a session, end a session, stop and resume a session with any mobile phone network over the world. The layered model that appeared with the ISO-OSI model has so many benefits in this subject, because this layered model allowed of separation of functions between the layers of the protocols. So a layer can be responsible of addressing, another layer can be responsible of the error recovery, another layer can be responsible of the session management. This is the session layer, this is the transport layer, this is the network layer. Another layer is responsible for the network access, which is called the data link layer. Every layer in the 7 layers has its own responsibility and is served by the upper and the lower layers to it to act as a sender and receiver for data according to the process being done. The most well-known computer network protocols that appeared over history was the NetBEUI, IPX, SPX, AppleTalk, and the well-known and very famous standard protocol TCP/IP. The TCP/IP is the standard protocol over Internet. TCP/IP stands for Transmission Control Protocol Internet Protocol. It's compatible with the ISO-OSI model. It provides interoperability between different hardware and software systems. Since it is standard, since it is compatible with the ISO-OSI model, it can be implemented by any of the hardware or software manufacturers over the world. It's open for development. It is not owned by a certain vendor, so it is open for development by researchers over the world. It provides reliability. It provides some sort of connection orientation. It provides some sort of error recovery and reliability in data transfer, as well as best effort delivery if this is the feature that is needed. And sometimes we need the best effort delivery feature when we are caring about the speed more than the reliability of the communication. This is very obvious in the real-time data, in the audio and video data. It is composed of a number of protocols. That's why we call it the TCP/IP protocol suite. It is composed of a number of protocols in the application layer, in the transport layer, in the network layer that are built over each other to form the TCP/IP protocol suite. It offers web browsing, file transfer, and email exchange. This means that it offers the most famous and the most demanded and the most wanted services over the internet. TCP/IP has produced version 4 and has produced version 6, and both are running. Version 4 is more common, version 6 is the next version, and it is the current version in some countries over the world for communication over the internet. This is the TCP/IP protocol suite. Let's have a look. Let's have a look at the upper layer that is composed of HTTP, FTP, Telnet, SMTP, DNS, TFTP, RPC, SNMP. These are all protocols in the application layer, in layer 7 of the ISO OSI, or let's say that it is in layer 7 and 6 and 5 in the ISO OSI model, and it is in the upper layer in the TCP/IP. The transport layer, which is the layer 4 in the ISO OSI model, includes here in TCP/IP two protocols. One of them is reliable, that is the TCP protocol. The other is unreliable, which is the UDP protocol. The network layer, the third layer in the ISO OSI model, is translated here into one layer that is called also the network layer, including the IP protocol as the main protocol and other protocols such as the ICMP, the ARP, the RARP, and the dynamic routing protocols. Here, this layer is responsible for addressing and routing. The lower two layers, the data link and the physical layer, includes some of the protocols responsible for accessing the network, for data representation, and the functionality of the physical and data link layer, such as the Ethernet, the token ring, the FDDI, the ATM. ATM here means asynchronous transfer mode, and ISDN, other protocols that are responsible of transferring data, representing ones and zeros, accessing the media, avoiding collisions, and such functionalities of the data link and physical layer of the ISO OSI model. Let's here have a look more in depth about the mapping between the TCP/IP and the ISO OSI model. The TCP/IP is 7 layers, we all know this, but the TCP/IP model is only 4 layers. You can see that the upper 3 layers has been merged together to form the application layer in the TCP/IP. The transport is still the transport. The network has been translated as it is with the name internet and sometimes called the transport as well. The lower 2 layers are the data link and physical and are called the network access layer in this TCP/IP. So let's say this again. This mapping between the ISO OSI and the TCP/IP has done through merging of some layers to be 4 in the TCP/IP model instead of 7 in the ISO OSI model. This has done through merging the physical and data link, keeping both the network and transport layer, merging the upper 3 layers into one layer called the application layer. The TCP/IP is now the default protocol that is implemented inside any Microsoft, Linux, or any other operating system that needs to be standard, that needs to connect machines over the internet. TCP/IP is now standard, is now built inside Microsoft operating systems, Linux operating systems, and other operating systems that are produced on machines needs to connect over internet. Let's now have a look at the mapping between TCP/IP, the ISO OSI. 3 layers has become 1 layer. Application, presentation, session has become the application. And example protocols that are running in the application layer of the TCP/IP are the HTTP, Telnet, FTP, SMTP, DNS, RIP, which means Routing Information Protocol, SNMP, which is Simple Network Management Protocol, DNS, the Domain Name System or Server, SMTP, Simple Mail Transfer Protocol, FTP, File Transfer Protocol, and Telnet is used for remote administration. The transport layer is mapped in the TCP/IP into host-to-host transport layer. This is mapped into either TCP in the reliable communications or UDP in the unreliable communications. The network layer is mapped to the internet layer. The IP layer is the main layer, that is the main protocol or the main layer working in the network layer. Upper to it we can find ICMP, Internet Control Messaging Protocol, or IGMP, Internet Group Management Protocol, and the ARP, which is the Address Resolution Protocol, which is responsible between the resolution between the two types of addresses, the MAC address, the IP address, the physical address, and the logical address, as we will see later. The data link and physical layers are mapped here into one layer that is called network interface layer and is implemented in several protocols in the TCP IP, such as the Ethernet, which is the most commonly used over today's networks, the token ring, the frame relay networks, and the ATM. This is the core of the TCP IP. This is the main mapping between the ISO OSI model and the TCP IP protocol. Thank you.